Right, good afternoon and good evening, everybody. Welcome to week 3 of these pre-recorded sessions. Today's will be continuing from the math skills from last week. So we're going to move on to look at measures of central tendency and dispersion. And then there'll be a second part to this where we'll go back to some neuroscience. And we'll do ways of imaging the brain, which is on the advanced information. So we'll cover the 4 that you need to know there. But we'll start with central tendency and dispersion. Now, this is part of the indicative mathematical content, and maths, as I've said previously, accounts for up to 10% of your marks across all 3 papers. So you do really need to know how to do it. If I can get my screen to share. There we go. So, measuring central tendency and dispersion, what does that mean? So these are the 2 kind of descriptive measures, we'd call them, that you need to know. So there's inferential statistics, which is your chi-square, your t-test, your Wilcox, your Mann-Whitney, etc. And then you've also got your descriptive statistics, so measuring how the average score, measuring how spread the scores are. So we'll start with central tendency. That is, think of it as average. Okay, so if you see central tendency as average, you're looking for the point in the middle to which the data tends, hence the name. And I've underlined in blue here what I'd say is a key definition if you're ever asked to explain what this is. Central tendency measures give us information about the most typical values in a set of data. So what the expected score would be if we were to pick a participant or pick a score at random, what would we expect to see? And measures of central tendency give us different ways of judging what that number would be. So the 3 you need to know that you will have come across all through your lives really in maths: numeracy, mean, median and mode. So hopefully these are familiar to you, but we'll go through each in turn. So mean is unique in that it's the only measure of central tendency that includes all the values in it. The median and the mode are unique in that way. So you add all of your scores together in your data set and then divide by the number of scores you have. So it's quite a simple calculation. You may be asked to calculate the mean. But you'll have access to a calculator in the exam if you take one in. So it's just adding all of the scores together and divide by the number of scores. So if we've got 10 scores, we divide the total by 10. If we've got 20 scores, we divide the total by 20. If we've got 38 scores, we divide the total by 38. And it is that simple. Because of this, it's the most representative score because it does take into account every piece of data in the data set. But because it considers every piece of data, it does mean it's more heavily distorted by extreme scores. So if you were to imagine that we have a graph of points and we're calculating the mean, and you've got one outlier that's right in the bottom corner of the graph, that's going to tug the mean towards it in ways that would be ignored by the other 2 measures. So that's a disadvantage of using the mean that we have to be mindful of. When there's outliers, it may not be the best choice. Median, so the middle value, if you think median, medium, middle, it is what it says. So you arrange all of the data from the smallest score to the highest score and then select the middle value. So if we were to arrange the numbers 1 to 10, if that was our scores, we'd line them up in ascending order, starting at 1, ending at 10, and we'd pick the middle number. In this case, it would be between 5 and 6. So you would then take the average of those 2. So if you can't take the middle number, so if you've got 3 fingers, you can take the middle one. If you've got 4 fingers, the median is between these 2, so you take the average of those 2. That's a very poor analogy, but if there's 2 middle scores, you take the mean of them, as we've already discussed. If there's 1 middle score, that is your median. Because you're only looking at the middle of the data set, it's not affected by extreme scores. But then the flip side of that is because you're not looking at the whole data set, the median is unrepresentative, as it doesn't include all values when you're calculating it. So there's positives and negatives to each, and you've got to evaluate which might be most appropriate when you're deciding which one to use. I don't think you'd be asked to do that. I think you'd be much more likely told what's being used, and you'd be expected to calculate it from a table, we'll say. Mode, the most frequently occurring value in a set of data. So you'll have, if you've got, imagine a table with scores saying how many people got 1 on a test, how many people got 2 on a test, how many people got 3 on a test, how many people got 4 on a test, etc. The modal score would be the score that most people get. So if most people score 6 out of 10, that would be your mode. It can be bimodal, bi meaning 2. So if you've got 2 most frequent scores, if let's say 40 people score 6 and 40 people score 4, and no one else scores higher than that, then the mode would be 4 and 6. Unlike median, you don't take the average of those two. When you've got categorical data, so the example I've used previously was people's favorite flavor crisp. So if you've got cheese and onion, salt and vinegar, ready salted, you can't take the average of those. You can't take the mean. You can't arrange those from smallest to largest to take the median. You can only select the modal score, the modal category. So we use the mode especially with nominal data, categorical data. Again, like the median, it doesn't take into account all of the scores, so it's unrepresentative of the entire data set. It doesn't tell you anything beyond what the most frequent one is, whereas the mean will give you information about the whole data set because we're using all of the scores to calculate it. Now, you do need to know how mode, median, and mean are affected or affected in a distribution. So if you've got the upside down, or actually what we call a bell curve in the middle, the normal distribution, the mean, median, and mode always align at the peak. The tricky aspect is when the distribution skews one way or another. So with the normal, it's easy, they're all in the middle. When you have a negative skew, which is where the peak of the curve is to the right of the graph, the mode is the highest score, or the highest of the 3 averages, I should say. And the mode is always the peak. That, unlike the median and the mean, that doesn't change. The mode is always the peak of the graph because that's the highest frequency. That's what the peak means, maximum frequency, as you can see on the y-axis there. The median is always in the middle of the mode and the median, the mode and the mean when it's a skew distribution, and the mean is in the lowest because the mean, if you can see my cursor here, is being distorted more. It's been pulled by these scores on the far left. Because the mode only looks at the most frequent score, that's not affected. It still gravitates towards the peak. And then with a positive skew, where the peak is on the left side of the graph, it's just the opposite effect. So again, the mode is at the peak, the median's in the middle, and the mean is towards the tail of the curve. So if you just remember whether it's negative or positive, the mean goes towards the tail, the mode is always the peak, and the median always sits between those two. You can't go wrong. The only tricky part is to remember which way around a negative skew is and a positive skew is. But negative skews towards the right, positive towards the left. Okay. Measures of dispersion. So these now give information about the spread of the scores, and that's the key phrase you'd use, the spread of the scores. The variation of the scores would be acceptable as well in a data set. And there's 2 you need to know, the range and the standard deviation. The range is very simple. It's just the difference between the largest and the smallest value in a data set. So let's say we've got some data here, 57, 59, 76, etc. We just take the smallest score and the highest score, and then subtract the smallest score from the highest score, and you get a value, and that value is your range. So the range is the difference between the lowest score and the highest score. In this case, it's 149. So that's quite a simple calculation you could be asked to do in the exam. You just subtract the lowest score from the highest score, and that's your range. Standard deviation, a little more tricky to grasp, but you'll never have to be asked to calculate it. You just need to know roughly what it refers to. So standard deviation allows us to calculate the spread of the scores around the mean value. So effectively, very crude terms, what it's telling you is what's the average distance from any given score to the mean. That is not exact, so it is crude way of describing it. But you're looking at how, on average, how much do the scores vary from the mean. So if you've got a big standard deviation, it means the average difference between a given score and the mean is very high. So the bigger the number, the greater the dispersion, the greater the spread, and that's quite simple to grasp. It's not very, it's very intuitive in that sense. You could be asked to interpret what a standard deviation is telling us, and I'll show you an example of that in a second. So if you've got a larger standard deviation, it would simply indicate that the participants are not being affected by the IV in the same way. Because imagine you've got a link between caffeine and memory, and you've got a really large standard deviation. That would indicate that some participants are being not at all affected by the caffeine, and that some participants are being greatly affected by the caffeine. Whereas if you've got a small standard deviation, all the participant scores are clustered around the mean, which would mean they're all responding to the manipulation of the independent variable in the same way, roughly. And because of what I've described to you, it's very mathematical standard deviation. If you could do psychology at uni, you'll learn how to calculate it by hand, joy of joy. But it's a much more precise measure because of that. Because with range, you're just looking at the extreme scores. Standard deviation is looking at all of the scores and seeing how tightly clustered they are around the mean. So here's an example of the kind of question you could get. Now, you'll be given a table that will give you the mean and standard deviation. You'll be asked to interpret it. Okay, so let's have a look at this. Researchers are studying male and female map reading ability and calculated the following statistics. So we've got the mean, the standard deviation for males and females, and we want to see what those values suggest about the performances of men and performances of women. So this would be a 4-mark question. You would get 1 mark for describing what the mean is saying in the most basic terms, and you get 1 mark for explaining what this suggests about males and females. So this is actually split 2 marks for AO2, 2 marks for AO3. AO2 would be just saying what the chart, the table says. Your AO3 would then be your explaining what that then suggests about men and women. And same for standard deviation. 1 mark for saying what it says, that's your AO2, and then a further mark for saying, going beyond that and saying what that suggests about males and females. So a sample answer here that we could say that would get full marks, very brief. You don't have to overwrite these kind of questions. Sometimes it's as simple as it looks like. So the mean score for males is almost 3 times larger than that of females, 1 mark, which suggests they are much better at map reading than females, 2 marks. 1 mark for stating the actual difference of the mean. We've got 15.4 for males, 5.25 for females, so roughly difference factor of 3. So you'd say the males are 3 times higher. That's your first mark. The second mark is then say, well, that suggests, well, it suggests males are better at reading maps than females. So, and it's as simple as that. You don't have to overinterpret, you don't have to overthink this. It is as simple as just saying, well, it suggests that one is better than the other. And that's it. That might seem like you're making the same point twice, but actually you're not. You're saying what the data says, and then you're saying what that suggests about your populations, your samples. Standard deviation, well, males 2.7, females 2.22, so actually they're very similar. So if you just say the standard deviations are very similar for males and females, 1 mark, this suggests the spread of the performances of male participants and female participants is similar within each group. So they're equally varied. That's your second mark. So there's 4 marks there. All you're saying is what this table says, and then what that suggests about the difference in map reading ability between males and females. And this is something you could very likely be asked. I think this is the sort of mathematical content I would say is the most likely to come up interpreting scores from a table. So that is actually brings to an end the first part of this session. Hopefully that was useful, and then I will see you for the next part of the session where we're going to have a look at ways of investigating the brain for biopsychology, which is on the advanced information. So hopefully we'll have another nice short video. See you there.